Hi everyone. In this video we're looking at trig graphs, and we're going to look at the trig graphs for sin x, cos x and tan x. And we're looking at them in radians. So just to sort of do a recap on radians here, pi is equivalent to 180 degrees and 2 pi 360. So these other measurements here would be 90 and this one here would be 270. So just so that you've got a little bit of a reference there about what you're doing here. So the first graph we'll do is sin x. And look, the easiest way to go about this is just to see what it looks like on your calculator. So sin x, and let's just plot it. So we'll go into graphs mode and put that in. There we go. So you can see we've got a bit of a wavy thing going on here. So this time I'll set my viewing window to be more accurate with what I've got here. So my x min goes from 0 up to 2 pi, and my y min goes from -1 up to 1. And there we go. There's a bit of a better idea there. So you can see that our graph starts at 0, 0, and then that maximum point, that 1.57, you'll become used to that, that's pi over 2. So maximum happens here, and then if we g-solve for where it crosses the x-axis, 3.1415, that's pi, so it crosses there, and g-solve for our min, and that is 3 pi over 2, and then we'll g-solve for our other root, and that's at 2 pi 6.28. And so when you're sketching it in, you've just got to remember that it's a curve that you're sketching, and so not a straight line, although I feel like I've just made that into a straight line. Let's just put that back. So a curve like that. There we go. So that's what sine looks like. Okay, let's have a look at the cos graph, and I'll just write that in, y equals sine x. So let's look at cos. So we'll change our graph to cos x, and there's our graph there. I might actually make my viewing window just a little bit bigger. If we make that -1.5 to 1.5, that's a little bit better there. There we go. And this one is starting with its maximum at 1, and it's crossing the x-axis here, minimum at pi, crossing again here, and maximum here. So sketching that curve in. There we go, that's what it's going to look like. So that's y equals cos x. So if we just compare those two, you can see that they're actually the same graph. It's just one is translated to the side. Okay, so they're different by it's being translated by 90 degrees or by 2 pi. Okay, the last graph that we'll look at is tan x. So we'll put that one in. So tan x. And you can see here that it's quite a different graph. In fact, we might even zoom out a little bit so that we can see it a bit better. Okay, so you can see here that we've got a repeating graph, and we've got asymptotes in there as well. But if we keep in mind that this graph is across 2 pi, we can see that it crosses here, it starts here, and it finishes here. So if I'm just sort of sketching it in, it's going to look something like this, and then coming in like that, and then going like that, and then the same coming down here like this, and so on. So that's y equals tan x. Now it's got a couple of features that you can probably see here. It's got an asymptote down here and another asymptote down here, and so you usually draw those features in when you're talking about a tan graph. Now usually when we're doing modeling with these trig graphs, it's really cos and sine that we use commonly for modeling. Tan is a little bit more obscure, but we can use it for modeling. But you should become familiar with those three types of graphs because they do crop up a lot in what we do. And then the next video I'll look at doing some modeling with these graphs. Thank you.